Aside from regulating the Earth's thermostat, the melting ice is causing the ocean level to rise. This is also a consequence of the general increase in sea temperatures. Warmer water simply occupies a greater volume, and half of the rise in sea levels is caused by precisely this increase in temperature. Scientists anticipate the sea levels to rise by at least half a meter, but conceivably even more, meaning that all cities around the world will be vulnerable to coastal flooding to an extent we don't yet understand. New York was hit by tropical Hurricane Sandy in November 2012 and suffered extensive flooding due to a 4-meter-deep storm surge. By the middle of this century, the sea is expected to have risen by a further half-meter. A half-meter sea level rise would only have a minor impact on Manhattan, as you can see here. But when coupled with the effect of a Hurricane Sandy-level storm, the picture suddenly becomes more dramatic. Another consequence of the deglaciation of Greenland, among other places, is the possible impact on the Gulf Stream, which is keeping the temperature stable in northwestern Europe. The deglaciation originating from Greenland contributes large quantities of fresh water to the ocean, reducing the salt concentration and thereby making it lighter. This can affect the water's buoyancy in the sea surrounding Greenland. This mechanism is keeping the Gulf Stream alive. The Gulf Stream will weaken, and this will affect wildlife in the sea, producing a colder climate in northwestern Europe. Since humans' natural habitat is above sea level, we're often unaware of what is taking place underneath the surface of the sea, even though it is very important for the absorption of the CO2 we emit. In fact, the ocean absorbs nearly 30% of CO2 emissions, but this has consequences. Back in 1880, when the atmosphere contained the anticipated content of CO2 of 280 ppm, the ocean looked blue and healthy. But when CO2 reacts with water, it creates carbonic acid, a reduction in the pH value, and the ocean becomes more acidic. This has a consequence for all living organisms who are using the calcium as building blocks. Everyone knows that you can use different acids to remove calcium from a coffee pot. More acidity in the ocean will therefore impair living conditions for crustaceans such as krill. Krill is excellent feed for both penguins and whales. But since the number of krill in the ocean has declined 80% in the last 40 years, it is threatening the very population of both species. The acidity levels in the oceans have a great impact on the well-being of the coral reefs, which are in poor condition worldwide. Both the acidity and the elevated temperature of the sea are killing the coral. Coral is very sensitive to its living conditions. In the latest episode, extreme El Niño-generated high temperatures in the sea surrounding Australia meant a large part of the Great Barrier Reef, the world's largest coral reef, was destroyed, leaving the reef almost extinct. The temperature has now dropped, and the reef is starting to restore itself. Some areas are starting to succeed, but the acidity and the temperature rise in the ocean are still present, and the reef might not recover completely.